Okay, guys, today's lesson is sticking with compounding, growing our money in an exponential way, which is what we want to do. But we're going to move from annual compounding to quarterly compounding and monthly compounding. I'm just going to read the first paragraph of the notes here. In the old days, banks computed interest using adding machines and other devices that we would now call dinosaurs. And since there was no email or online banking, or mobile banking for that matter, people used to keep track of their money in their accounts with little folders called bank books. It was a noteworthy advancement when banks went to quarterly compounding. The use of quarterly compounding is still important because most stockholders receive dividends. Remember, we've talked about dividends, which are income from owning stocks or bonds, on a quarterly basis. By reinvesting these dividends, putting them right back into your stocks, we get the benefit of quarterly compounding. So remember the formula and the work we did last time with annual compounding. The formula is here. Oops, I'll take that one. The principal is equal to the initial principal. So the ending value of the investment, P, is equal to the initial value of the investment, P sub 0, times 1 plus the interest rate as a decimal to the power of T, which is time in years. The only difference with quarterly compounding is, well, there's two differences actually. Notice that the interest rate is divided by 4 and the exponent is multiplied by 4. This means you get 1/4 of the interest rate. Now remember, that's an annual interest rate, so it makes sense if you're getting paid quarterly, though you'll get 1/4 of that rate each quarter. That's what the bank does, or the investment vehicle. They break that annual rate up into 4 pieces and pay you once every 3 months or once every quarter. That's the bad news, that your rate is getting divided by 4. The good news is that you're getting paid 4 times more often, 4 times per year instead of once per year. And that's why you would multiply T by 4, since T is years. Okay? And it says here that this doesn't amount to much when the amount invested is small or the interest rate is small. However, when those numbers get large, it makes a larger and larger difference. So here's an example. Find the value of $1,000 invested at 4% annual interest for 5 years when interest is compounded quarterly. And there is the key. So still dealing with annual interest rate, APR. It's a 4% annual rate. That is APR. I'm going to write that up here because we're going to see that over and over and over. Okay, the answer is given here. We're going to end up with $1,220.19. But let's go ahead and calculate that. Okay, we're going to take that $1,000. We're going to grow it. How do we grow it? We multiply it by 1 plus something. It's got to be bigger than 1. We're going to take the interest rate, which is 4%. I'm going to convert that to 0.04. That is 4%. Remember, 4 over 100. And we're going to divide that by how many times we break this up in a year. And if we're doing quarterly compounding, which we are, we're going to divide it by 4. Okay, how many times are we going to multiply by that? We're going to multiply by, we're going to repeat that multiplication 4 times every year. And since we're dealing with 5 years, we're going to raise it to the 4 times 5. That's the 20th power. So we're going to multiply it by itself 20 times. Now, if you don't have Desmos, I'd recommend getting Desmos on your calculator. You can type that in as written. You don't have to worry about the order of operations. If you are using a standard phone calculator, you just have to be a little more careful. What we need to do first is 0.04 divided by 4, right? And that is division in the order of operations. Inside parentheses, and then division before addition. 0.04 divided by 4 is 0.01. And we're going to add that to 1. Oops. So I could do a few things here at once. I'm going to take 1,000, turn to blue. 1.01, and we can do 4 times 5 in our head. So now we're looking at, that's a bad 20. 1,000 times 1.01 to the 20th. Still have an order of operations problem. Exponents before multiplication, so I'm going to take 1.01 x to the y on your iPhone, and probably something similar on the Android. 20 equals 1.220. So 1,000 times 1.22. Looks like we're going to have a 22% increase on our initial investment. I'll just leave that number in the calculator and multiply it by 1,000. Actually don't need to do that in the calculator, silly. Move the decimal 3 places to the right. And we're going to get 1,220.19. That looks like what's written here. Excellent. Okay, so annual compounding, if we had done just treated the 4% as an annual compounding situation, we would have taken 1,000 times 1 plus 0.04 to the fifth. We would have ended up with $1,216, so we made out better. And simple interest would have only given us $1,200. Okay? Quarterly compounding. Let's try another one. This just reiterates the fact that if you do reinvest the money that you receive from quarterly dividends, you're basically getting quarterly compounding. So if and when you invest, and hopefully you do, once you start making money, and you start getting dividends from those companies that you are invested in, they will offer you the opportunity to automatically reinvest. And if you just do that, you won't miss the money much, and your money will be growing by quarterly compounding. Okay, let's try another example here. Vanguard Natural Resources currently pays 10% annual dividend. How much would you have in 30 years if you invest $1,000 now and your dividends are reinvested quarterly? Okay, well here's the formula. And we're going to assume the annual dividend remains the same at 10%. Okay, well, we're going to have to divide that annual dividend percentage by 4 to make it a quarterly dividend. And we have 30 years of growth. That's a nice long-term investment. Let's check it out. It looks like the answer's down here. We're going to end up with another $9,000. We're going to end up with $19,000 on our $1,000 in 30 years. That's just a one-time investment. Let's make sure that's correct. So let's take the 1,000. We're going to multiply it by 1 plus something, and that something is 0.10, 10% divided by 4 to the power of 4 times 30. That's 120 payouts or growth periods. That's going to be 1,000 times 1 plus 0.25, 0.025 rather, to the 120th. And that is indeed, let's see, 1.025 x to the y. 120 is 19.35814 multiplied by 1,000 is equal to $19,358.14. 19 times your original investment. And if you could afford to invest even $1,000 per year in a fund that earns 10% annually, you would have the beginnings of a nice little nest egg. Well, how about monthly compounding? Let's say that we get the benefits of compounding even more frequently. So not just quarterly, but every month they grow our money. Very similar. So once you know one of these formulas, you'll know the rest. In this case, the annual rate will be divided by 12. So they're going to split it up 12 ways. However, the number of years will get multiplied by 12 because you get 12 growth periods per year. There's the formula. Let's try this example. Darn it. Even that happens. All right, example 3. How much will a $5,000 investment be worth in 12 years if you receive 6% annual interest compounded monthly? That's what you're looking for. How often is it compounded? Take the $5,000 and we're going to grow it. That means multiply by 1 plus something. The something is 0.066% divided by what? 12. To the power of 12 times 12. 12 growth periods every year for 12 years. It's going to be 5,000 times 1 plus 0.005 to the 144th power. Okay, 1.005 x to the y. 144 is 2.0507 times 5,000 is $10,253.75. Not too shabby. Note the rule of 72 says you'll double your money in 72 divided by the interest rate. Remember the rule of 72 from last time. 72 divided by 12 is 6. Oh my goodness. Go away. 72 divided by 12 is 6. And, 6%. So it's about double your money, about $10,000 with annual compounding. So we're going to do better than double our money in 6 years here. Remember the rule of 72 applies to annual compounding. So we can get about an extra $254 compared to annual compounding. Like I said, that gets better as the amounts of the investments go up and the interest rates go up. Okay, the guided practice is for you. Give these problems a try. You'll see a link to the PDF on Classroom, and submit your work via picture on email, or you can send me a picture in Remind. Good luck, guys.